Hi guys, this video is going to be on the remainder of chapter 3, which will deal with contingency tables and Venn diagrams. A contingency table provides a way of portraying data that can facilitate in calculating probabilities. It helps in determining conditional probabilities quite easily. The table displays the the sample values in relation to two different variables that may be dependent or contingent upon another. So suppose we are studying the speeding violations and the driver's use of cell phones. Produce the following fictional data here. All right. So as you can see in our first column, we have the speeding violations. In our second column, we have no speeding violation. However, in a contingency table, you may have rows also that kind of counteract with using the other information. So this row is going to be uses a cell phone while driving, and this one is going to be does not use the cell phone while driving. All right, so let's jump right into some examples. So the first one asks us to find the probability of a driver is using a cell phone. All right, so the drivers that use a cell phone, if we scroll all the way over and we look at this, this should be 305. So that should be 305, and our bottom box always tells us our grand total. One thing I do want to say about contingency tables before I keep going is hypothetically, if totals are not given to you, you will have to find the totals of not only the different columns, right, but also the different rows. All right, so that's just one tidbit information that you do need to know. All right, so if we have the users of cell phones that are driving, that would be 305, like I stated, and our grand total will be 755. All right, so 755 or 305 divided by 755 will be our probability that a driver is using a cell phone. To find the probability that the driver had no violation in the last year, right? No violations in the last years. Now we're looking at it. We're looking at this actual column here. So no speeding violations last year actually sums up to be 685. We don't care about the cell phone uses. It's just asking us solely about the violations from last year. So that'll be 685 divided by 755. Because again, we still want to use the total number of people throughout this whole study. Now, find the probability that the driver had no violation last year and was a cell phone user. So now I have to wean in and control a certain amount of information. So I am looking for not only not having a speeding violation, which will be in this column here, but then I am also looking at who is going to be a cell phone user. So that pinpoints us right here to 280. So that will be 280 divided by 755, because again, we want to go by our grand total. That's a bad color to use, so I'm going to use a different one. Okay, so my next question asks us to find the probability of the driver is using a cell phone, or, here's the key word, or the driver had no violation in the last year. Now, if you remember, or dealing with the probability means that we have to do the probability of A plus the probability of B minus the probability of A intersection B. Okay, so I think we've done a lot of the work ahead of time. The probability of a cell phone user, right, a driver that's a cell phone user, was 305 out of 755. The probability of a driver with no violation last year was 685. That would be your probability of B, right? Minus the probability of the driver had no violation and a cell phone user would be 280. Okay? So remember the probability A, so this is the cell phone driver, this is no cell phone, and this is probability of C intersection N, right? So just remember, If it says or, you must do the probability A plus the probability of B minus its intersection of the two information. Right? So if we pull this up, this means that we would have 305, turn it on, 305 plus 685 minus 280 gives me a whopping 710. So my answer would be 710 divided by still the 755. Remember, when you're adding and subtracting fractions, the numerator changes, not the denominator. Okay? So let's do another example. It says find the probability that the driver is a cell phone user given, now we have another highlighted word that I put in caps, given the driver had a violation last year. So let's go back to our contingency table. We are looking for the probability that the driver is a cell phone user given that they had a violation in the last year. Okay, so if we look at this information, cell phone users, that's here, violations, that's here, who does it meet in the middle? 25, right? But when I said given, that doesn't mean we use a total of 755. That means now we're only using the total of 70. So my answer would be 25 out of 70, I'm sorry. Okay, now find another example, since I'm trying to make it quick for you. Find the probability that the driver had no violation last year, given, again, this keyword given the driver was not a cell phone user. Okay, so driver is no violation and is not a cell phone user. Okay, so if I erase all my little extra marks here so we don't get confused, I am saying that the driver has no violations. All right, so no violations is here. All right, given that the driver is not a cell phone user. So not a cell phone user would be this row. So where does that meet for us? That meets us at 405, right? But the reason why I am only going to use 405 and what is this? 450 is because I use the word given that the driver does not use a cell phone. So the given really indicates what your grand total that you want to use, okay? So our answer would now be 405 divided by 450. Again, the given is indicating what your bottom number will be. All right? So, Venn diagrams, if I move quickly on to the next part. Venn diagrams is a picture that represents the outcome of an experiment. Right? It generally consists of a box that represents the sample space S together with two circles or ovals. Well, let me not say two. It could be two, it can be three, it can be four. The circles and ovals represent the events. Okay, so let's do an example. I forgot to type example. So example one, or my only example here, would be 40% of students at a local college belong to a club, and 50% work part-time. 5% of those students work part-time and belong to a club. Notice the emphasis that I'm always using, right? Draw a Venn diagram showing the relationships. Let C belong to the club and PT belong to the students who work part-time. So if I look at this, don't want to give it away just yet. If I look at this, I can say that my first circle can be my C, right? This would be C, okay? And then my second circle would be the PT, and the space in between would be the C and PT, right? Now, what does C represent for? C represented for 40%, if I'm not mistaken. 40% of the students at the college, all right, so belong to a club. So that will be 0.40, right? Now, where did I get 0.40? We don't use percentages while we deal with probability. We use the decimal form of it. So 40%, right, is 1, 2, equates to 0.40. Okay? Now, for the part-time. Part-time is now in the category, right? Make it a little thicker. Is in this right-hand corner, and it'll be 0.50, right? Now, the space that comes in between the two, it says 5% of those students work both part-time and belong to a club. So this will be the 0.05. Oh, that's a dark color. Okay, so 0.05. All right, so that's our Venn diagram. Now, it did say that it's usually indicated with a box. We can put the box over the top, and then we have ourselves a Venn diagram. Now, let's see if we add up all to 1. So 0.4 plus 0.5 plus 0.05, that means we have some extra information hanging on the outside. So 0.4, oopsies, just make sure I got my right answer. 0.4 plus 0.5 plus 0.05 gives me 0.95. So again, we have some space that is hanging out on the outside here, which will be 0.05. All right. So my next question, oopsies, my next questions are really dealing with us understanding if we can find the different probabilities. Okay. So for my first question, it asks us, if a student is selected at random, find the probability that the student belongs to a club. So I've already kind of found that information for you. The probability of C would be 0.40, okay, because it's already given to us. What is the probability that the student works part-time? Well, what is that? The probability a student works part-time is 0.50. Okay? Now, boop, boop, boop. I left one out, so I do need to put it in here for you because there is one on your homework. So, find the probability that a student works. It is really read as P of C, the complement of C, right? Or you can see it as how I did it in class with a little dash over the top. Remember, the complement usually means that we have everything that's added up, right? And we want to subtract it from what we have, right? So, technically the complement of C, so what is in C? C has 0.4 and technically a portion of 0.05, right? So that would be 0.05 plus 0.40, right? Which gives us a 0.45. And then from this whole general thing of a complement, what's left over in the set? So what's left over in the set should be 1 minus 0.45. So 1 minus 0.45 should give us 0.55, if I'm not mistaken, right? I may be wrong. Let's double check. 1 minus 0.45 gives me 0.55. Okay? So then that's how we found the complement. We added up what was left in what we had in our circle for C, what was in between our circle, right? And then we subtracted it by 1 or whatever was left over out here. We could have easily just looked at this as well to see what was hanging out outside of C too. Okay? Now, so now we're going to skip on down to this example here. The probability that a student belongs to a club given, highlighted the word given, that the student works part-time, we can say that it will look like the probability of C divided by probability of part-time, P of T, right? So, the best way to find this, okay, will be the probability of C and probability of part-time divided by the probability of the part-time. Now, I did kind of skip over this, but the probability of C and P, college and part-time, right? Well, that was easy. It says it up here in the information. The probability of those both is 5%. So 5% in the decimal is the 0.05, right? So I just didn't rewrite it down. So this will be 0.05 or 0.05, all right, divided by the probability of part-time. So the probability of part-time will be 0.50 or 0.5. And then when we divide that together, we should end up with 0.1. That is how we find that given situation when we're not given a contingency table. All right. Now, let's do our last one, which is the or. Do we remember what we have to do for or? So it says the probability that a student belongs to a club or works part-time. So that means we have to do, again, the probability of C plus the probability of part-time minus the probability of C and part-time, right? Okay, so the probability of C is 0.40. The probability of part-time is 0.50 minus that intersected space would be minus 0.05. So when we put this in our fancy dancy calculators, we have 0.40 plus 0.50 minus 0.05, and that will give us 0.85. Okay, so just again, remember when we're dealing with this or, you always have to deal with this setup. Probability of first plus probability of second minus the probability of what the intersected space is. Okay, and that is all for this video.